Shader stripping is used to get rid of unused variants to reduce memory and loading times of your project. For simpler ones, Unity does this process automatically for you, but once you start messing around with the behavior of shaders at runtime, you will have to start to do it on your own. So I have a simple small project here with some red spheres, and when I start, you will see that they switch the colors to blue sometimes at random time intervals. The way you would usually do this is by adjusting the color using, for example, a material property block or changing the material directly. However, in this project, I did it a little bit differently using shader features. So let me show you the HLSL code first. And as you can see, I wasn't lying. There is indeed a keyword here called shader underscore feature. And it is basically working similar to macro definitions like in C, if you know that language. But essentially, these features allow us to conditionally change the behavior of a shader. So, for example, if the keyword blue in capital letters is defined in the material or shader, we reach this branch here below and change the color to, well, blue, of course. And if red is defined, we change the color to red. However, you might know that GPUs are not very good at handling branches without a significant loss in performance. Therefore, this is not your typical control flow. Instead, what actually happens is that a shader is generated for each possibility. I say this twice because this is really important. This if statement is not evaluating anything, but instead two shaders are generated, or shader variants. One variant that contains all of this code, and one variant that contains all of this code. This type of behavior is also called static branching. Now you might start to see a problem. Here I have a shader, for example, that not only has more colors, but it can also be transparent or not. So the number of possible shaders is 4 times 2 is 8. And if I were to add another feature, for example, I might want the material to be affected by fog. We would already have 16 possibilities, and you see how the amount of variance increases exponentially with the amount of features we have. Okay, let's go back to the project. Like I said in the beginning, Unity typically manages and removes shader variants automatically. And the way it does this is to scan all your scenes in the build settings and all assets that are referenced by those scenes, and looks at which variants are actually used in the project. And once it has collected all these variants, it removes the rest. This works very well unless you change the behavior at runtime, like I'm doing right now with these spheres. Unity then has no way of knowing that you will need a variant in the future, so to speak. So it will work fine in the editor, but as soon as I build this and start, yeah, nothing happens. Luckily, we can tell Unity not to remove the variants of a specific shader. For that, we open up the project settings, go to graphics, and to always included shaders. And here we simply add our shaders, go back to the build settings and build again. And it works. But what if we had 1,000 variants or 10,000 variants? Then that would be a problem again. Because everything is included, this will occupy a lot of memory. And it all has to be loaded in because we don't know what we will actually need when we run the game. And this is precisely the point where we have to remove variants again in a manual fashion. And I will show you how to do that for our small example here right now. First we create a new script. Let's call it something like shader processor. Make sure that the script is in your editor folder, not your runtime, and open it up. So it's not a mono behavior. We don't need this code. It implements a specific interface. It's called preprocess shaders. It has a certain method called onProcessShader, and this method gives you a shader, some additional information in the snippet data, and a list of all the variants it wants to compile right now. And so all we have to do in this method is to remove the variants we don't want from this list. You can also have multiple processors here, and that's why you need this callback order, but right now we can just set this to 0 and it's fine. So first we iterate through all the data like this. Here I have defined some keywords that we want to remove. So we want to remove all the variants that contain the keywords green, yellow, and semi-transparent. Now we loop through the keywords we want to remove. And then we simply check if the keywords that are currently set contain one of the keywords that we want to remove. And if yes, we remove the shader variant from the list. And yeah, that is basically all there is to it. Alright, now that you know what shader stripping is, you might be wondering why the hell you would even do this in the first place. And you're right in this case. You could as well change the spheres to any color you want by material properties blocks or by just changing the material color, and it would be far better than using shader variants. But let me give you a few use cases. So one example would be an options menu where you want to change the quality of some shader and you have predefined sets of keywords that define the low-end shader and the high-end shader, and you switch them out at runtime. Another situation where you are likely to use shader stripping is if you use Unity's addressable system, because Unity is not able to automatically find all the shader variants necessary because they're never referenced in the scenes themselves. Alright, and as a bonus tip how to remove even more shader variants from your project, you have to realize that not only are these variants compiled for each shader, but also for each shader stage. So in this case, red, blue, green, and yellow is not only compiled for the shader, but for the vertex stage ones and for the fragment stage ones. So each variant is basically twice in memory. And if you, in this case, for example, we only use red, blue, green, and yellow in the fragment shader. And the same is true for opaque and semi-transparent. So what we can do is we can add this fragment to the shader feature, and now it will only compile for the fragment stage and not for the vertex stage. So you can remove even more variants from your project. Thank you for watching, leave a like, leave a follow, and most importantly, as always, leave money on my bank account by buying one of my Unity assets. Link to the store plus link to the project are in the description. Bye.